The new section is entitled Perpendicularity. How about we get into the first problem? Suppose you were told that two lines are perpendicular. You are given that A is perpendicular to B. Okay, for some reason that didn't write, so let's do it again, and now it will write. You are given that A is perpendicular to B. Things that are perpendicular are lines or rays or line segments. And it's not going to matter, but suppose I tell you that they're lines. You have two lines, A and B, that are perpendicular. And you're also given this picture, angle 1 and angle 2. So you were given that A is perpendicular to B, and you would love to prove that angle 1 is equal to angle 2, as opposed to angle D, excuse me. So you want to prove that those two angles are equal. Now, what you need to realize is that this is a straight line. So that's 180 degrees. And if the lines are perpendicular, well then that's 90. And that's also 90. In fact, you don't even have to mention 180 degrees. You just have to argue that angle 1 and angle 2 are both right angles, and as a result, must be equal to one another. And the proof will be as follows. Proof. So let us get some, let's label this. The point of intersection is O, and we have point C, and point D, and point E, and point F. Okay. So let point C and F be on line B. Let points D and E be on line A. So we have some points on the lines now. And on line A, and also let point O be the intersection of line A and line B. Let O be the intersection. Okay. So now we have the picture. Well, since A is perpendicular to B, we have EOB, angle EOB equals a right angle. EOF, excuse me, I'll change that. EOF is a right angle. EOF. But that's angle 2. We have angle 2, which equals angle EOF, is a right angle. And angle 1, which is COE, is angle COE, is a right angle. Angle 1, so angle 1 equals angle 2, since all right angles are equal. Since all right angles are, I hate the fact that they don't say equal, but they use this strange word congruent. All right angles are congruent. So I feel that that's proven. Okay. Next problem comes, say, with this picture. MOP and R. MOP and point R. And you are told that you are given the following information. You are given that angle MOR is equal to 3x plus 7 degrees. And you're also told that ROP is equal to 4x minus 1 degree. And you are further told that MO is, and this is a symbol for perpendicular. That means they meet at right angles. It's perpendicular to OP. Those two line segments are perpendicular. MO and OP are perpendicular. That means they meet at a right angle. You want to know which of these two angles is larger. Which of these two angles is larger? Now you can't base it on the fact that 4x is bigger than 3x. If x is relatively small, then multiplying by 3x and then adding, quote, a lot, 7, that might make it bigger. For example, if x is 1, 3 times 1 is 3, plus 7 is 10. If x is 1, you have 4 times 1 is 4, minus 1 is 3. It turns out that the 3x was bigger. But if x were 10, for example, 3 times 10 is 30, plus 7 is 37. And the bottom one, 4 times 10 is 40, minus 1 is 39. And this time, since 39 is bigger than 30, the 4x minus 1 was bigger. So I think in this problem, we're going to have to figure out what x is. Okay. Now, since it's a right angle, the sum of those two parts will be 90 degrees. And this angle is MOR, which is 3x plus 7. And this angle is ROP, which is 4x minus 1. And on one hand, when I add them up, I get that. 3x plus 4x is 7, and 7 plus negative 1 is 6. And on the other hand, it's 90. Those two angles add up to 90 degrees. So this must be 96. Why? Not because it's 7s or x's, but because 96 minus 6 is 90. 96 minus 6 is 90. So 7x should be 96. 7 times, well, 7 doesn't go in there evenly, so let's do some division. So x is equal to 96 over 7. Not the friendliest answer. Excuse me one moment, please, but 7 plus minus 1 is plus 6, sorry. So, let me just come down here. 84 plus 6 is 90. This here is an unknown number, plus, and I know what 6 is, it's 6, equals, and I know what 90 is, it's 90. This must be 84. 7x must be 84. 7 times 12 is 84. So x is 12, okay? So we have 3 times 12 plus 7, which is 36 plus 7, which is 43. We have 4 times 12, which is 48, minus 1 is 47. This one is larger. 4x minus 1 is larger. 4x minus 1 is larger. That is angle ROP is larger. Question was, which of those two angles is larger? First you had to realize that that big angle was 90 degrees, and the sum of the parts that made up that 90-degree angle adds up to 90 degrees. Sum of the parts is the whole. Okay. Now, suppose you have this picture right here. Angle 1, angle 2, angle 3. And let's just name this point A, point B, point C. And you are told the following. AB is perpendicular to BC, and you are told that angle 1, angle 2, and angle 3 are in the ratio 1 to 2 to 3. 1 to 2 to 3. Okay. So that means instead of 1 to 2 to 3, you call it 1x, 2x to 3x. That is angle 1, I'm going to call 1x, and angle 2, 2x, and angle 3, 3x. And the question is, what's the measure of each angle? Well, I know, now since AB and DBC are what? Perpendicular, I know that this is a right angle. So the sum of the angles is 90. So angle 1, which is 1x, plus angle 2, which happens to be 2x, and angle 3 is 3x. The sum of these angles add up to 90. You need to know your 6 times table. 6 times 15 is 90. So x is 15. So 1x is 15, 2x is 30, 3x's are 45. For 1x, that was angle 1. 2x, that was angle 2. And 3x, why, that was angle 3. The angle 1 is 15 degrees, angle 2 is 30, and angle 3 is 45. If I called that 1, if I scaled it down to 1, well, this is 2 15ths. This is 3 15ths. The ratios are 1 to 2 to 3. If you have 15 to 30 to 45, you can divide each of these numbers by 15. And you get 1, 15 over 15 is 1, 30 over 15 is 2, and finally 45 over 15 is 3. It's 1 to 2 to 3. The real angles can be any multiple of those numbers. You want the multiple to be 7, they can be 7, 14, and 21. Angle 1 can be 7 degrees, angle 2 can be 14 degrees, angle 3 will be 21 degrees. Of course, they wouldn't add up to a right angle. But if the 3 angles were in that ratio, it could be that number. But since we wanted the sum to be 90, it had to be 30, 45, and 60. Sorry, 15, 30, and 45. Okay, I hope that was clear. Okay. Try the next one. Suppose that you are told that angle HGJ is equal to 37 degrees, 20 minutes. And angle KGJ is 52 degrees, 20 minutes. Remember, 20 minutes, well, 60 minutes make up a whole angle. So that 20 is a third of 60. It's a third. So it's a third of a degree. I know this is a bit big for 1 degree, but if that was 1 degree and you broke it up into 3 parts, they'd each be 20 minutes. The sum would be 60 minutes or 1 degree. Okay, so you're given this, and you're given that KJ is perpendicular to HJ. That is exactly what you are given. And you're asked to conclude the following, that our HGK, that angle, is HJK. HJK is congruent. Show that those two angles are in fact congruent. HJK. Okay. So let us see what we have. We have two angles, and they both have side GJ. Okay? GJ. You have HGK. Actually, let me just draw it this way. You have HGK, HGJ, and you also have KGJ. Now maybe and it's a right angle, because they're now telling me that, let me draw this first. Apparently something went wrong. KJ and HJ, they intersect at J. You have that KJ and HJ are perpendicular. That means they meet at a right angle. Okay, so how about we start off there? Now let's do the first angle, HGJ. Now that actually makes no sense. HGJ. HGJ, KGJ, KJ, HJ. KJ and HJ. Now, angle H. Okay, well, let's see. We know this is a right angle. HGJ. So G is, say, somewhere out here. HGJ. And KGJ, which is that angle. Okay. So, now the thing is, if you have 37 degrees 20 minutes and 52 degrees 40 minutes, well, the 20 minutes, plus 40 minutes, that's 1 degree, so I carry it over. 7 and 1 are 8 and 2 are 10, carry. It adds up to 90 degrees. Well, for this to be 90 degrees, it turns out that we have a square or a rectangle. Turns out that G must be here. K, J, and H don't move. But for the sum of these two angles to add up to 90, actually we have a rectangle, not a square. For the sum of the angles to be 90, let me actually live up to what it says. KGJ, good, is 5740. And GJH, or HGK, HJG, this is 37 degrees, 20 minutes. Okay, so it turns out that's also a right angle. Now they want us to prove that HGK which is this angle here, is congruent to HJK. Oh, that's a lot easier. You didn't even really have to draw a picture. You didn't really have to even draw a picture to do that. The picture did help me see it personally. Well, we know that, okay, so we're given that KJ is perpendicular to HJ. Well, that means, so our KJH. Remember, this is the same as JH. I don't mean to do that. That's the same as JH. And since J is common, you just get KJH. This is a right angle, which is 90 degrees. Okay. Now, we have HGJ, and we want to add KGJ, which is the same as JGH. So, in other words, if you have HGJ and you want to add, oh, something went wrong there, didn't it? HGK and KGJ. Oh, excuse me. This is supposed to be K. I just reversed the order. Instead of KGJ is JGK. JGK. Okay, the sum of those two angles, JGK. Let me write this as K. I'm still troubled by this. Okay, so I'm troubled because I'm just going to put K out here. HGJ is this angle, and JGK is this angle. Well, I just added up those two angles. I just added them up and I got 90. So we know that we already knew this because they told us that the two lines met at right angles. So KJH was 90 degrees, and I just argued why that's 90 degrees. So yes, they are congruent. They are congruent. The sum of the parts is the whole. Now, since I wanted to add them, of course, I should have put the other angle out here so I can add on more. I don't want to put K here because I wouldn't be adding on anything. But I wanted to add on. Okay, so that was motivation to put the K out there. Or the first way I did it, drawing that picture, I concluded I had a rectangle. Okay, try one more. You're given that AB is perpendicular to BC, line segments, and you're also told that angle ABO is 2x plus y degrees, and angle OBC is equal to 6x plus 8 degrees. And you're also told that angle AOB is 23y plus 90. degrees, 23y plus 90 degrees, and you're told that angle BOC is 4x plus 4 degrees, and you're being asked to find the measure of angle ABO. The measure of angle ABO is how much, and you are given some picture, given a circle, given A, B, C, and O. Don't want it to look like our isosceles triangle. No need for that to be the case. So here's B. And you're given O. Okay, so AB is perpendicular to BC. I mean, that's the right angle. ABO, so I'm going to draw this a lot bigger. A, O, C, I'll change that in a moment. And you have B, you have your right angle, and O. And you have, let's go one by one. ABO is this angle right here, which is 2x plus y. And OBC is the other piece, is 6x plus 8. 6x plus 8. And AOB is 23y plus 90. 23y plus 90. That's that angle, AOB. And BOC is this angle right here, which is 4x plus 4 degrees. And they want to know what ABO is. ABO. That is, they want to know what 2x plus y is. So now, we have two ways of ultimate, at least in theory, to get this. We can actually figure out what 2x plus y is without knowing what x and y are. I mean, if somehow we came to know that 2x plus y is 72 degrees, we'd be done. That's one way. Another way is to know that x is 10 and y is 20, and to double x to get 2x, and add y, and say the answer is 40. So either we find out what x and y both equal, or we find out what 2x plus y equals. Okay. So we have two things going on here. Just give me one moment and I'll mention it. We have this right angle at B. That is, when we add 2x plus y and 6x plus 8, on one hand, when we add them, we get 8x plus y plus 8. On the other hand, we get 90. Okay, that's one equation. This big angle is a straight angle. They add up to, those two pieces add up to 180 degrees. 23y plus 90 plus 4x plus 4. When you add them, on one hand you get 23y plus 4x plus 94. On the other hand, get 180 degrees. So those being these two, these are my two equations. And I'm going to need some more board space to solve them. But in the end, I want to know what 2x plus y is. Okay. This first equation, what I'm underlining must be 82. 8x plus y must be 82. You know why? Because if it's 82 and you add 8, you really do get 90. If you have 94, what are you adding to it to get to 180? Well, 4 plus 6 ends in a 0. That adds up to 10. Add 8 more, get 18. The 23y plus the 4x must be 86. There are two equations, two unknowns. In my opinion, the easiest way to solve this is, I don't want to multiply by 23, but I'm going to multiply this equation by 2. That will give me an 8x here, and there already is an 8x in the first equation. So when I double this second equation, I get 8x's plus 46y's. When I double 86, I guess I get 172. And the other equation I'm just copying down. And I know one thing. If I subtract, the x's cancel. 8x minus 8x is 0. 46y minus y is 45y. And 172 minus 80 is 90. And I know that 45 times 2 is 90. So y is 2. Now, I can find x from, say, this equation. Right here, please. 8x plus y, which is 2, is 82. So that must be 80, because 80 plus 2 is really 82. So 8x is 80. Now, rather than finding out what x is, I'm going to divide by 4. I'm going to divide by 4. That way I find out what 2x's are, because I want to know what 2x's are. Remember, I want to know what ABO is. It's 2x plus y. So, if 2x is 20. Now, just for the record, if you didn't like that, if 8 times x is 80, x is 10. Well then, 2x would be 20, and y is 2. So 2x plus y is 22 degrees. And that finishes that problem, and it finishes the section on perpendicularity. Okay, good luck with this stuff. It's fun, isn't it?